Hi, I'm Sean Gannon, and this is Minute Math. And today we're going to learn about differentiation. We're going to apply the product rule. And this one here is what we call a critical thinking question. So if I was given this question, we have a classmate. So a classmate, he claims that, parentheses, f times g prime is equal to f prime times g prime. Okay? So he's kind of changed what he thinks of product rules. For any functions here, f and g. What I want to do is show an example here that proves your classmate wrong. My classmate, I haven't had classmates in a while, but classmate wrong. He's wrong. All right. So we're going to find an example that shows that our classmate is wrong. We know the real product rule, and it's written right here. If we take the derivative of a function, it's really f times g prime plus g times f prime. So how can we show that our classmate's wrong? Well, if I was given this, let's say an example. Now, there's actually many answers that can show this, prove this. I'm just showing you one way here. If my example was this, if I said f is equal to 2x and that g is equal to 4. So if I said f was equal to 2x and g was equal to 4. So by his logic, or him or her, whatever, our classmate's logic here, we would say that, well, f times g all prime, right? He says is f prime times g prime, okay? Well, f times g here, f times f being 2x, so we have 2x, times my g, which is 4. The derivative of that should equal each one individually. Derivative of f prime is just 2, and derivative of g, which is just 0, okay? Well, 2x times 4 is 8x, and we need to take the derivative of that, right? The f primes are saying that I need to take the derivative of that. I know it's not like legit math showing here. Well, 2 times 0 is 0. Derivative here of 8x is just 8. So we have 8 is equal to 0, and that's not true. So that kind of shows here that his claim, or her claim, or whoever's claim it is not true. That this idea that f times g all prime is not equal to f prime times g prime individually, because when I showed it here, f times g came out to be 8x, and when I took the derivative of that, I got a positive 8. If I did f prime individually, which is 2x, to be 2, and g prime individually got me 0, our derivative of 4 being 0, multiply that, got me 0 here. 8 was not equal to 0. Again, I know this little notation here isn't the best way to do it. I really should have said that, f times g is some new function, whatever, but no, that's a little promise that I'm taking the derivative of that. I know some people in the comment sections are going to destroy me and saying, well, you should have written this nicer, whatever. That's what we're doing here. I'm kind of showing that right there, the derivative of that. So, excuse me, that's what we're seeing there. And so we can see by basically taking a claim and showing us an example where it doesn't work, then you say the whole claim is false. Now, be careful. You might have just picked two random, especially if I just picked two numbers, right? If I just took, with no variable, this one being 2, just 2 without the x, and this 4, and I did it, it would have been left and right were equal, fantastic. It almost could not prove, but make the person think that their claim was correct. But you have to find a few of them, or test some different things out here to show that it's incorrect. Because once we can find one way that it's incorrect, that means then this claim is incorrect in general. Okay, so it's kind of easy to prove that something's wrong in that way. And that's it. That's how we can. That's our little critical thinking question here. A little recap there. Critical thinking question here. Basically showing our claim here that this fake product rule isn't a real product rule. Okay, and then basically left and right side were equal from examples. This example for values for f and g that we came up with.